Right, good afternoon. Welcome in. Right, I'm Bob Hill. I'm a chartered building surveyor. I'm a buildings archaeologist with the IFA, and I've been, spent most of my working career dealing with historic buildings, one shape or form or the other, for, let's say, several decades on that one. And there are certain aspects that come up all the time in respect to that. One is cracking, which we dealt with some of that today with trees and other movements and subsidence. The other one is damp and all the constituents of damp. I'm not looking specifically at damp in more modern type buildings today, things with cavity walls. I'm looking more traditional structures, solid wall structures, and traditional roof structures, that type of thing. So it's looking at that type of building. So that start off with the age range of the properties I'm going to be looking at much as this. It starts off turn of the 17th century, when we're starting to get the change from what I term very vernacular buildings into more modern types of structures, type of building we're looking at now, and going up to about 1945. You could say 1939 if you wanted to, because between 39 and effectively 1954, in fact, effectively no building happened in this country. You know, due to the war, everything went into the war effort, and immediately after the war, there was no money, there was no materials about, apart from national reconstruction. And so, as I said, nothing occurred whatsoever. If you wanted to build anything, everything, you had to get a license from the Ministry of Supply, and those were on very, very short numbered generally. So during that time, there was also a huge change in types of building materials that were being used, and also the type of labour and the craftsmanship that were going into buildings. Before the war, you were looking at buildings which were quite traditional. You had a labour force which went through a traditional apprenticeship model, anything between 3 and 4 years. After the war, you got into a whole new range of materials. A lot more industrialisation, a lot more prefabricated units, everything from walling panels through to timber roof trusses, a lot more manufacture of joinery items, that type of item. And the big thing that comes about is the huge change from lime mortars and lime concretes over to cement or Portland cement based materials. And so that is the whole thing. We're also going other aspects from the traditional lime based plasters over to more what we're now classed as traditional gypsum type plasters, the pink plasters. So big lot of changes happened on that one. And the other thing that comes into that effect as well is the introduction of building regulations, which until about until that period had been rather ad hoc to where you went all around the country. And then you have the introduction of the national building regulations across the whole of the UK in 1963, which have then been updated and modified and taken on from there. So what we're looking at here is damp in walls, and that's all types of wall structure right the way through. From the ground up to the eaves, or from the eaves down, whichever way the damp is coming from at the time. And we're looking, and I'm going to be talking about traditional types of construction. We're looking at brick, stone, rubble, timber frame construction, and again, within that, I'm thinking of the more exposed type of, timber structure as the second from the right there, where we're looking at big piece joinery, big piece wood being used, rather than the timber framing which was coming in the 20s and 30s with things like cult houses. Just after the war, you have the Swedish style and Scandinavian houses coming in on that type of framing, and then develop on through into the 70s and 80s when there's the big takeoff with the hidden timber frames, which again have got huge problems with damp at the time, which stalled the whole use of that really until about the 1990s, when they took off again with a bit more construction. And we're also then looking at the other type of construction as up on the right hand side there, mass construction, rammed earths, chalk, mud walls and that type of thing. So this is the type of structure that we're going to be looking at. And then within the whole of that aspect, the various damp types you can get within walls and where they're coming from and where the damp sources are coming from within that. So predominantly walls with no cavities. Having said walls with no cavities, it's very easy to get the impression that cavities again are a modern feature. Cavity construction starts coming into domestic building or domestic use in this country from probably about the 1870s. It starts being known as hollow wall construction. Cavity is sort of generally sort of a post-war phrase. It's hollow wall construction. It's not always recognised, it's not always clear from looking at a building on the outside, because in a lot of the properties, certainly up until the early 20s, you have a wall which can be quite large, anything up to sort of 450, 500 thick in a larger type property. And within that wall, you'll have an outer face which can be a bond which appears to be a solid construction, a Flemish bond or an English bond type. The only way you're really going to check it in that intervening period, like I said, certainly from 1880 through to about 1930, certainly check your wall structures. And when you're measuring through a wall, make sure the walls are coming out at a nominal brick module width. So that's something about 225 thick, or a series of that. So if it's a brick and a half thick wall, it's going to be a nominal 225 plus 110 for half brick, and then perhaps 15 mil as an internal finish. If you're then getting a cavity wall coming into, that's going to be between 50 and 75, which throws you well off that brick or brick and a half module type of thickness. So it's well worth checking to see what you're actually having the damp in. Don't assume because you've got, like I said, one of the traditional bonds on the face and not stretcher bond, don't assume that it might not be a cavity wall or a hollow wall. So that's the sort of thing we're looking at. So if we go from the top down or from the bottom up, rising damp as it is perceived and for which many people sell apparent cures for. If it is actually something there. You've got falling damp, stuff that's coming down from the building. So again, that can be anything from roof level downwards, and that one. Penetrating damp, as it says, it's coming through the wall structure. If it is coming through the wall structure and it's not entrapped in the wall structure, because that again is when we come down to the bottom one there of condensation. All too often we are finding more and more problems of so-called penetrating damp is condensation. It's a locked-in dampness. And there's all sorts of reasons for that. One of the things when you're looking at dampness, it's that assessment. How are you going to judge how damp it is? It's perception. There's the good old one at the top there, which is the Mark I human. Can you smell it? Can you touch it? And can you see it? It can be very subjective as to that. It is how good are you at recognising the potential problems of damp. If you go into somewhere and you've got patches of black mould up the walls, the wallpaper's falling off and the plaster's coming off with it, and you've got mushrooms growing out of the fabric, you've probably got damp. Equally you can go into an older property, it's been shut up for years, the last person in there kept cats. You're not going to smell very much. On that aspect, I was out to look at a property a little while ago, and some elderly lady took me into a very nice dining room, parquet floor, and she said, I've got terrible problems with damp in here. And over the parquet floor there were patches of black staining, almost as good as that tablecloth there. And these were particularly concentrated on and around the carpet, big carpet under the dining room table in the middle of the room. Pull that back, and you can see the edge of the carpet, the black stain coming up to it. And it was also very noticeable when you got down close to pull the carpet out. I said, have you ever had a dog? And she said, oh yes, I had one. It died a few years ago. And I said, well, that's probably a problem. An incontinent dog. Because you had it was going around, particularly on the carpet, under the dining room table, but she never noticed it. And it was soaking down into the wood block, staining that. And in fact, the acids were leaching some of the bitumen back up into the wood block. So that's it. So you can smell it at times. Electronic testing, the traditional proteometer, the 2 prongs in the wall. Can work. Needs a degree of judgment as to how you use it. Manufacturers them say sell it on the basis for testing dampness in timber. Fine, if you've got a nice piece of raw timber in the timber yard, you can prod it into that and you'll get a good reading from it. If you're prodding into a piece of timber in an older type house, how good is that reading going to be? Because that's working by just electrical contact resistance between those 2 prongs. If you're prodding that through a lead-based undercoat on a 1930s skirting board, how much conductance are you going to get from that? So you've got ostensibly a perfectly dry piece of timber, which is going to give you 18-20% moisture reading because of that high conductance of the paint. So again, it's that aspect on that. Similarly, if you're looking, and it depends on where you are in the country, if you're down in parts of the West Country, if you're out in the Central Midlands, you're using an aggregate that's got a lot of dolomitic sandstone or minerals in the plaster. That's going to be inherently conductive. You're prodding through wallpaper that's got metal print foil on it. It's these aspects. Take a degree of judgment on it. Also, if you go into a property, middle of March, a nice foggy, misty day, no heating's been on there for 3 months, and you're down to sort of ambient air temperature and humidity, you could well be up to 20% just on the wall surface through natural air movement. So again, you prod that in there, you're going to see it's damp. So it needs a lot of reading. The sampling method with the quick meter, speedy meters, fine, very good if you're allowed to go in and do that. If you're buying a new house or if you're doing a new house survey, that's classed as intrusive. People don't like you getting the drill out and taking a sort of a wall, sort of dust sample out of that. So that can be a problem. There's the newer option. We've gone for one of those things. It's as the bottom picture there. Very simple little infrared cameras. They're becoming affordable, and you can now have an infrared type adapters. Even you can get an infrared attachment on a normal pocket phone, which can be very good on this one. This is a problem that we came up against. It's cold bridging from an outside wall here, surprisingly, cold bridging coming on through, and it's a dry lined wall, and it's actually picking up the plaster dabs behind the dry lining. So that's the thing. So that's the type of thing you do get from that. I'll leave it at that, have a look at it afterwards. And you can also take a full picture right from the plaster. Right?
How much was that?
That piece was, that was about 600 quid.
The phone ones are about £200.
Pardon?
The phone adapters are about £200.
Yeah, that's right. Yeah. That's about £600 for that one. It does photographs. You can take a full photograph of it if you want it, and so it's quite rapid. Again, needs a degree of interpretation. That is assessment. And so when you're looking at it, at the whole aspect of damp, how damp is damp, that comes under the basic question. That's a spare picture we've got in. So again, that's a sort of penetrating damp, which if you're seeing it, you're probably going to think, we have some form of damp in here, but what sort and where is it? In this particular case, We've got a raised ground level to about that level, so that's probably accounts for some of the reasons why we've got apparent damp coming through there. And I say apparent because it might always be pure damp. And the basic question is there, should it always, you know, when you're looking at a wall, do you always expect it to be dry? And if so, how dry? Thoughts? Should it be dry?
Yes.
Yes?
No.
Okay.
I've seen your next slide. No.
Okay. 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 So, not always. I've used COP here as an example because even in a lot of traditional housing, if a lot of surveyors, if they're finding readings of around 12%, they're going to start to worry. Particularly if they're using a prototype meter. But it might not always be that case. Look at the material that you're working on. Look at the age of the building, also the day that you're doing the survey on. So don't always assume that that you've got to be a totally dry fabric in its own right. Can we start to look at some of the aspects in here of rising damp? So we're going to start from the wall and come up through the structure. Damp will work, or rising damp will predominantly work through capillary action. It's how far it will draw the damp up through the fabric. If you can, most of you probably remember back to days at school with the capillary tube, with a coloured tube of coloured liquid and a whatever. It works by air pressure forcing anything down and then back up a narrow tube. It's drawn up by the surface tension within that tube. In this country, that will normally be about 1 atmosphere, 28 inches in old money, about 840 mil normally. As air pressure varies, that's going to go up and down slightly. So it might come down to about 810, 820 mil. It can go up to about the 900 mil. So that is a sort of area that if you're getting rising damp, moisture is likely to rise to. That moisture will be above the level of the highest ground that's attached to it. So here we've got a traditional spread footing type wall, solid construction. So I'd expect to see capillary action coming up to about 840, 1 atmosphere above that ground level. If we're looking at something, as on the middle picture, on the right there, so on the left, there you've got the higher ground level, and so that moisture level, that capillary action will be to the higher external ground level, or above any DPC or barrier level you've got in there. So you've got that coming up through there. If you've got a wall in traditional construction and it's able to breathe, as it's known, it's normally built of largely vapor permeable materials, as most traditional construction was, then most of what will happen here is that wall will dry to the outside. That basically occurs through having differential air temperature differentiation of vapor pressure within a building. Most days in this country you're going to be slightly warmer inside and slightly cooler on the outside. If that happens, then again, basic physics will tell you that the warmer the air, the more moisture it will hold, and therefore you can expect a higher vapor pressure on the inside wall here than you can on the outside. So therefore, if that wall still remains inherently vapor permeable, then that will move through the wall because the vapor pressure will push it outside. And therefore, anything that comes up through the wall here will also tend to dry to the outside, because you've got the higher pressure vapor pushing it through to the outside. Once it gets outside, the weather will whisk it away. It will air vent, it will dry out from the outside. And so really, if this wall remains largely vapor permeable, that should function quite well. And therefore your damp inside here, if anything, should be fairly minimal, if anything at all, because it's gradually drying through the outside. There can be circumstances, which I'll come on to in a minute, where you can end up with some apparent problems of damp in an area such as here, but that can be largely through to air circulation, which I'll come on to. Where you have problems with the base of the wall, such as, I won't say problems, but you have features in the wall, you know, a plinth ledge or something like that at a lower level, that can give you a catch point. So you can end up with, particularly in heavy rain, a localised saturation from that there which can come in. But that's going to be something which you'll find in any feature anywhere up the wall. Where it's a string line, where it's a large projecting wrap-round windowsill, window hoods or whatever. That can give you localised problems, and therefore you may need to do some localised weather protection in that area. But again, we'll deal with that one in a minute. So really, if this wall is functioning well, it should dry well and properly to the outside, providing that wall surface is permeable. And it's this whole aspect of permeability, which is one of the things which we find is increasingly a problem. You know, that walls over recent years have become far less vapor permeable. And that can be due to all sorts of things. It can be through plastic paints being used on the outside of buildings, but primarily it's where walls have been repointed using hard cement mortars. And hard cement in its own right is quite an impermeable material. It will reduce the amount of moisture that can be passed through it. So really, coming back to the whole thing here, you should always try and keep the ground level at most at floor level, external ground levels. Sometimes you can't do that. In that case, if you can't, as in here, you can't get that ground level down, then you may have to consider some internal barrier system. But I would say that use that as a, you know, very much as a secondary option. And again, avoid bridging of damp-proof courses and so on as that, if there is a damp-proof course on the outside. Damp-proof courses come in all sorts of shapes and sizes, which we'll again have a look at in a minute and go on from that. So really what we're looking at here is that this whole aspect of look at where the damp is and how it is being seen and how you're perceiving it within the whole of the fabric. And it's that various signs and what, you know, what you're seeing from penetrating damp, or rather, sorry, from rising damp in this case. I mentioned damp-proof courses. Another question for you. When do they come in? When would you expect to see them in properties?
1920s.
Yeah.
1920s?
1875.
1875 there. Anything else?
1880.
1880s, yeah. Anything else? And another 1920s. Right. Around about the 1880s. That's when we're starting to see them coming in there, in the better quality houses, and then as you know, it gradually comes down through lower grade qualities of houses after that. All sorts of forms. Sometimes you see them as, and again, very much a regional aspect. Sometimes you'll find them as a course of engineering bricks or something around the base of the walls. You know, either a blue brick, a dark red brick, depending on what area you're in, around the base. Broken, jointed slates are another typical aspect to see. Very often the only way you'll pick those up is look for a slightly thicker mortar joint around the base. Sometimes there you've got to pick off any pointing that's on the top of it just to check out under the base. Lead sheets, sometimes in a Hessian sleeve, or the more modern, slightly more modern sort of bitumen Hessian types. And then again another Midland one which tend to be typical, and that was the bitumen mortar course around the bottom. That tends to be noticeable on the back of a house out of the sun. The mortar very often has softened over the years, has run out, so you get mortar run, you get bitumen runs under brickwork below it, and a joint about so thick, whereas on the back it's about so thick. You know, just where it has softened and run out. So really, when we're looking at the base of a traditional solid wall, that's the type of structure we're looking at, you know, for this sort of rate, in about the 1880s. And then shortly after that, we have the introduction of the cavity, you know, the hollow wall, and that's coming in. Similar sort of footings at the base. Dampproof, of course, is being built in. And this is what I was saying earlier about the thickness of the wall coming through. You've got a traditional thicker wall at the back here, not necessarily a half brick as we see it nowadays with a cavity, but a thicker wall on the inside. But an outside wall very often laid in a more traditional bond appearance. That's what I'm saying. So measure through here, and if you're not getting a traditional brick bond thickness, then assume you might have a cavity within it. Plinths. That's the plinth from the base of the wall. A feature in the bottom of walls, again, very often in a lot of traditional housing, these were used as drying zones. You get in the lower part of the wall up out of the ground, so anything which is at all water soluble, can be damaged by water ingress, is being protected. You're possibly using a softer stone or a softer brick above the splash level. You're getting up above the capillary action zone. You know, so you're bringing it up sufficiently high. The end picture on the left, and also the second one in there, they've got timber framing, brought up on a stone plinth to get it up out of the splash zone from the eaves and off the road around it. That's on the far right, on the far left. That's also being used there as a levelling course on a sloping site, so it's got a dual factor. In other structures, that is this, you've got a monolithic structure, very soft, very susceptible material, which in this case is cob, and that's raised up again on a plinth base of, in that case, flint work, to get up and out of that capillary zone, and it's allowing that to act as that evaporation joint. The other one here, a softer stone with even softer stone above it. To some extent, it's been used as a sacrificial zone. That's getting battered, it's suffering from erosion, and so it's in that area. Here we've got a rendered down face of the wall with an architectural style print from the bottom, but still within the bottom there's a DPC, but the DPC hasn't been breached, it's been left exposed. All too often, where people have gone in and repaired plinths or rendering, that DPC is breached. And so we go back to the picture we were looking at earlier on, you're getting moisture transferring around the DPC and nullifying the whole effect. So that, you know, can give you problems. If you've got a solid wall, you've got problems coming up against it, you want to try and correct it. First of all, find out if there's a DPC. Have a really good look around the property, see if you've got a DPC. It's easy to go around and look around, and there's nothing visible. Has the ground level come up sufficiently high to have bridged it? It's an amazing number of properties you'll look at where people have put paving up against a wall. They level up to a door. They put a flower bed around it, and they brought the ground level up to it. Really check out if whether you've got a DPC in there or not. And that's it. Anything after about 1880, certainly about 1890, be suspicious if you're not seeing a DPC in a house. And in the case, if you can find a DPC, get that ground level lowered below it, and then let it dry out. It may be a case that in lowering it, you've got to do some repointing because the brickwork's eroded, where it's been covered or bridged. So get that whole lot down. If you haven't got a DPC in there, or even if you have, get the ground lower down it. We'd recommend putting in a French drain and subject to how far the floor is below ground level, take that French drain down to at least internal floor level, or ideally 150 mil below internal floor level, and then run it out through to a suitable run-out point, and make it a worthwhile one. It should be something at least about 300 mil wide. Line it with something like Terram to stop any soil creeping back in and contaminating the granular fill within it. So it needs to be constructed reasonably well, so you're getting the static water pressure away from the base of the walls that you get from normal soil, and you're also allowing that granular fill to allow the base of the walls to lose moisture. It's an evaporation trench coming in here. And the other thing is splashing on the base of the walls. Get rid of that. If you've got splashing right against the base of the wall, ask the question why that's happening. Block gutters, missing gutters, inadequate eaves throw. You've got other water discharging it from a different source. So again, that's all introducing water into the base of the wall. So get rid of that, all those water sources as much as you can, right the way down through the whole of the structure. Allow the base of the wall to breathe, and as I was saying just now, get it to breathe properly and easily. So that's removal of, we say that, impervious wall coatings and finishes. And don't just take an impervious coating to be 2 or 3 coats of, a modern plastic masonry paint. And when you're looking at those impervious coatings and paints, and if you're specifying them on a property, look at the overall permeability of them. You have a lot of paints, a lot of the big manufacturers saying, whatever they're saying, breathable paints and whatever. When you actually look at the permeability of them, they're about as permeable as a co-op, carrier bag, and they have a similar effect on the property. If you keep your hand in a plastic bag all day long, just see how much water drains out at the end of it. That is the amount of moisture that these things trap into a building. Cement mortar, as I was saying just now, that will trap moisture into the joint, because a lot of these joints, particularly where you've got a harder type stone or a harder type brick, that's where you're going to be losing most of the moisture through, actually coming out through the joint rather than through the material itself. And it's because of the use of these hard cement mortar, that's where you get a lot of deterioration of brickwork and stonework, because the moisture then starts to come out through the fabric, and that causes breakdown of the stonework. So just make sure you're getting that whole level that much lower down. This one, here we've got a problem here. It's rubble stone brick banding within it. The upper part there is in traditional lime mortar. The bottom bit's been repointed in a cement mortar. You can see how much darker it is because of how much more moisture entrapment there is within it. That's the whole thing. And on the lower picture there, the classical render with the hard cement render over-coated with masonry paint. And I don't know if you can quite see it from there, but this house has had a lot of damp problems. Ground level is about the same as floor level internally, and they've got a lot of paving and a lot of borders all the way around it. They've also had some very effective damp proofing firms in and around the area, because they had one firm came in in response to saying we've got damp in our walls, and so they've injected a Dampproof course through here. You can see the holes there. Evidently not worked, because someone's come in a little bit later and put one and a second one in, just above it. But in both cases, they've left the render on there, which bridges the Dampproof course that they've put in. So it's effectiveness on the whole thing. The other thing to question about injected Dampproof courses is their effectiveness and whatever. The Building Research Establishment did a lot of testing on all sorts of them, silicon, electro-osmotic, the vent tubes back in the 70s, 80s when they were very popular, and their conclusion was that We can't prove they don't work, but generally the remedial work you need to do to install them would be sufficient to correct the damp in the first place. So that's it. The other thing as well is that, particularly with the silicon type damp courses, silicon isn't a void filler. It's a water repellent. So if you can get it injected into a wall, it will repel water from granules that it touches, but there's any voids, any cavities or anything else, again, which will still allow capillary action to run through, it won't fill them. You don't get a cut-off as you would do with a mechanical insertion of a damp-proof course, such as a lead sheet or a bitumen plastic sheet being put in through it. So it's the effectiveness of it. So when you're looking at a newer replacement DPC, be very careful as to what you're specifying. Do you need to put one in, and what sort you're going to put in? And all these ones which come up with a 20, 30, 40-year guarantee, how good's the guarantee? Are they insurance backed? And who holds insurances? So be very careful on that when you're looking at putting these in. And again, go back to the BRE recommendations on insertion of damp-proof courses, and there's some very good information on that. Falling damp, probably a lot more easily identified when you're seeing it. You know, classic one is around chimney roof abutments. I know it's not strictly walls, but it can be, where you've got that water going in, and you can look up, you've got displaced flashings to chimney stack. You've got top to coping stones all the way around the top. It's where you're seeing water coming down the inside face of the building, and there's all sorts of areas that they can come in through cornices, through string lines, fell and gutters and whatever. You can see them in all sorts of places. Invariably high level within the building. Up close to whether you've got a joint within the buildings we mentioned just now, a change of direction in the fabric, somewhere outside where water is catching on the fabric and coming in and then dropping down through itself. Second one in from the left, classic one, in a bay window, failed gutter eave structure coming in over the window head. This one is within part of within a roof structure, under a valley gutter that runs up through here, under a roof pitch, within a closed roof void. You know, this is a mansard type roof. This is when you get in behind it. There you've got water coming in around, you know, a parapet gutter area and coming in through. And it's very saturated in there, right through to how wet the insulation level is in here. And the other levels such as this, where it's, again, high level water coming into the fabric right the way through. To correct that, generally it's mechanical work to be done. Replacement of defective gutters, cleaning out gutters, hopper heads, and whatever, leaking joints in downpipes, gutters, whatever, flashings, tree growth. It's that whole aspect. A lot of this is good maintenance work. And it's also often which isn't happening to a lot of, you know, a lot of our stock at the moment. You know, sort of, people don't like going up too high. And again, this whole aspect of things, you know, houses and buildings last forever. You don't need, you don't need to do anything with them. You know, a lot of it comes down to education of the owners and the occupiers, as to they need to make sure that, you know, their fabric is being kept together. But there's also the other areas where they're looking right up high. As I said, chimney flashings, parapet flashings, such as up here, all those areas up there. Those are all areas where you're getting water coming in at high level. It's draining in. You know, water's lazy stuff. It just takes the easiest route away from anywhere, and so it'll just come down. It'll come down. Penetrating damp. What's coming in from the outside? Fairly straightforward. Generally, if you've got holes in the fabric, or you've got fabric that isn't inherently, I wouldn't say waterproof, but damp resistant, moisture resistant, and it's still largely unsealed. It's coming in through the capillary action of the fabric you've got on the outside, if you've got particularly porous materials. Soft brickwork, soft stones, that type of material where it's driving in, or it can drive in. As long as it gets enough time to get onto the surface and percolate in, that's where it's coming from. You've got the catch points on the surface, as I was saying, ledges, stringline, tops, cornices, that type of area, they can all come in. The driving rain, very much with the permeability, that's often associated with poor pointing. Poor pointing isn't necessarily because it's got line pointing, it can equally be because it's defective cement pointing. In fact, very often is more so defective cement pointing where you're getting moisture trapping in behind that and it's not easily able to be evaporated the outside surface because of the impermeability of the cement-based material itself. It has a very high shrinkage rate on drying. You get a lot of micro cracking in there, so moisture can get in and then it takes that much longer to come out again. Flashings we mentioned again, as we did just now, at high level. Get a whole series of flashings all the way down through. When you're coming into aspects of that, there's a whole lot of other data you can have on the sort of thing. Imperfect external coatings and finishes, hard renders, again, full of micro cracking. Masonry paints, which are failing because they shrink back like mad. Plastic has a huge coefficient of expansion and shrinkage on it, so you'll get a lot of surface cracking on that. And again, lack of availability for that to dry out for the outside. And then, the classic defective pipe work on the outside. Doesn't have to be downpipes, it can be overflows continually running, boiler expansion pipes, evaporation pipes from the condensing boiler, all sorts of things that you can give you localised water sources. And it's again where you're seeing it, where it's coming in. Around windows, frames, window perimeters, where it's driving in throughout, where they've been improperly sealed in, all the external caulking around the frames have failed and it's creeping in around that, particularly on a driving face. Timber framing, as in this example here, it's actually coming in through a decayed peg hole in the timber framing, and that's then sort of coming, it's on a face that's catching the weather, so this needs to be looked at. Or we have this area here, where again, another piece of timber framing, where in that case the whole wall over the years had bowed out, so it was bowing out slightly, catching the weather, and it was running, water running down the face of that and then running back in across the top of the timbers and then down the face of the wall internally. And so again, that was it does. And then pure penetrating damp work, such as that in a localised corner. And that's a combination of wind and rain eddying around a corner of a building, and in this case particularly exacerbated by blocked gutter overflowing at that end and then really being saturated, where it's being blown in and around. So, corrective action, much as before said, ledges and flashings, get those dressed over so water is being thrown clear of the building. You're not having a position where water can come in and settle onto those sort of areas. Sort of aspects as that. Here we haven't shown it on the top on there, because there's none on there, but ledges like that on a cornice. If you want details of good lead dressing like that, the Lead Sheet Association has a whole series of downloadable PDFs of lead flashing and lead flashing details, which you can just, if you go onto their website, you can pull those off there. Very, very useful resource, for that type of detailing, particularly if you're dealing with historic buildings and conservation officers, so on, really want to know what you're doing. So that's the lead sheet association. Impervious coatings, make sure that they, well, ideally are removed. Take them off and replace them. Depending on what the quality of the building you're working on, if you've got a listed building or a building in a conservation area, you may well need listed building or conservation area consent to do that, to take off and renew. If you're just doing a small piece of patch repair on external render on a listed building, you might get away with it as maintenance repair. But if you're going for more comprehensive strip and replacement, then you're going to need appropriate consents. Because again, they allow the building to absorb moisture but then give it back to the external air afterwards. And that's the whole thing. What can soak in will soak out again at the same time. So it's the whole thing. So when we're looking at the whole thing, it is that whole aspect of looking at the repair and the maintenance of the building, make sure that it's as waterproof as possible. So when we're looking at a building like this, we've got 3 areas to look at for potential damp ingress. So where you're most likely to be seeing these elements and why. So just an exercise for you there. Let's start with it, rising damp. Where might you expect that? Ground level? All ground level or localised ground levels?
Around the space, suspect, isn't it?
Yeah. Yeah, you've got quite high, you've got a terrace in here, right up to ground level there. Yep.
Around the vegetation,
Yes, potentially so.
that corner where the air vents and blocks are there.
Yeah. Although here, if you look, the ground level's dropping away here, so your floor level's going to be reasonably high. You could have rising damp, but it's going to be how much area? It's also suggesting, I think, on here, by that top of that plinth line there, right, we've probably got a damp-proof course in there anyway. So it's probably not going to be so much the problem for around most of the building, except you're saying, someone said, in the localised areas such as around on the left-hand side there, with that bay window, a raised terrace, where you might be up against it, or some other areas where you've potentially got a bridging of that DPC, if there is a DPC in it. But for the quality of the house, we've probably got one running in just on top of that plinth.
Will
Right,
the
right through.
plinth cause, will the plinth bridge the damp course?
In this case, no, because you've got the shoulder of the plinth
Yeah.
just below the damp-proof course, so that's going to run any water off and away it.
Is the damp-proof course visible then on the pit?
It's that slight grey line running just through there.
Is that slate then?
That would be a slate one, for that age of property. Yeah. That's up at Welbeck. That's the rectory at Welbeck. That one. Okay.
Leaking gutter?
Okay. So falling damp. That's going to be the next one. I think we've got several examples of that.
The balcony above the counted bay.
Yep. Probably was that one. We've got a vape, but the amount of water staining down here. We've got a lot of problems on that one there. Similar problems with that one. And that's it. And then I think with penetrating damp, again, sort of the whole southerly aspect of the wall there, all those ledges over the head of the windows, those are all places that you're going to catch damp, and water's going to come in there. There's also where you have areas such as this, we've got cornices like this. How well is any decking over there flashed into the building, and things like those parapets connected into the building as that. A whole lot of potential areas where we're seeing both penetrating and other aspects of damp. Another clue here we've got, as well as that damp proof there, we've got a lot of damp staining up under here. So it's suggesting we get a lot of wind eddy around the top part of the building there. We're getting damp brought back a long way around that sort of main weather face. So again, that's the sort of place we end up with localised damp penetration coming back through the fabric in those areas.
Whereabouts is the house?
But
Location?
This is up at Welbeck. Yeah. Pardon? North Yorkshire. Yeah. 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 So again, it's a whole lot of area there. Another area to consider, oh sorry, I didn't point out, was a valley there which doesn't appear to have any linings to it. So it's, again, there may be hidden linings, but you know, it's a whole lot of other areas. Look there about that which can give you problems. One of the things that I've mentioned just now is this whole aspect of whether you've got damp or you haven't got damp. Interstitial condensation. This is a problem which is coming very much to the fore now as to how sort of buildings work or they don't work in terms of damp. And very often when you have interstitial condensation is you're going to see it on external walls, and it can be diagnosed as all the forms of damp that we've been talking about. It can be diagnosed as penetrating damp, falling damp, or even rising damp. But it's where you've got moisture trapped within the fabric. It's particularly where you have, as in this case here, you know, we've got an impervious coating the outside of the wall. It stops the wall breathing. As we were talking about just now, if you have a warmer room here, inside, your vapour is going to be at a higher pressure water vapour, and then outside, you're going to have a lower pressure water vapour out here. So that, well, the breathable wall will pass through, and so that will work away. But at some point, as with on a wall of this type, particularly on a cold day, as cold temperatures as this, you're going to have what's known as a dew point forming. That's when any moisture vapour passing through that wall will hit a point where it cools and becomes free water, and it's absorbed into the fabric. In normal circumstances, if this wall can breathe, it will then be whipped away by the wind, by the general climate outside here, and so will dry out. If it can't breathe, then that becomes trapped in the wall. So with our theoretical wall here, we have a wall of purely consistent quality, density and type right the way through. So we have a nice even temperature gradient, where as the moisture passes through the wall, it gradually cools to the outside temperature.
What happens when you put gypsum plaster on the inside?
Well, if you gypsum plaster, it's still going to be vapour permeable. But this is what I'm saying. You know, this is our theoretical wall, because in a real wall, even as a solid wall, you've got mortar joints in there, and so those will all upset the sort of theoretical thermal gradient. So this is a theoretical wall with a nice even construction right the way through. So with this wall, as the moisture passes through, and so it comes on through. So in this case, we have our nominal dew point just on the outside face of the wall here, where the water is now condensed back from a vapour into free water. The trouble is, because of the way this works, because the water can't evaporate to the outside face of the wall, the water then accumulates against this impervious lining and then saturates the wall. Once the wall becomes saturated in that area, it loses its thermal capacity. It can't hold the heat, it's cold, and it then comes down. And it effectively becomes the same temperature as the outside air temperature. And therefore our dew point has then moved further back. That then has the effect of cooling and saturating the next section of wall as it comes back. And so gradually the wall will continue to get wetter and cooler until you can end up with having the effective condensation point, the dew point, on the face of the internal face of the wall. Very often that's noticeable when, for some reason, someone comes along, they take a picture off the wall, there's a big black patch behind it. They move a big chest of drawers out from the wall surface, and there's a big black patch of dampness behind it, big patch of mould. It's not mould at this height, as you might expect for normal rising. It's this height or whatever. It is where it's coming further and further up the wall. And it's largely caused by walls being kept totally impervious to moisture vapour. They become saturated, they become wet. I've had cases where we've looked at that for clients. I've got the speedy meter out to do the dust sample, drilled into the wall, and the drill core has come out with toothpaste on it. It's no dust at all. It is saturated right through the internal face. And so that is some of the classic problems of interstitial condensation, and more often we're seeing that on houses. They're sealed tight, and so they are presenting signs of classic dampness right the way through. And all too often, a lot of so-called damp specifiers or damp corrective people are then coming in and saying, right, what we need to do is we line the inside face of the wall. We're saying to hold the water back. And all you're doing is hiding that and trapping inside the face. Alternatively, they'll say, we've got penetrating damp, we'll give it a couple more, we'll give it a coat of silicone on the outside and another coat of impervious water paint. Which again, exacerbates the problem. Very few are going back to the aspect of saying, right, strip all the outside off and start again and make it fully permeable and fully breathable. So that is one of the big things really needs to be considered. So, as I was saying here, you can see it all over the face of the wall at effectively any level. It can be localized patches, it can be big blobs, it can be a whole mosaic of patterns all across the wall. Often behind pictures or anything on that surface which is causing an entrapment of air behind it. And basically, as you're going through your zone, it can be seen at all times of the year. It's not just a localized one. Surprisingly, it often is more identified in the middle of summer than it is in the winter. Because in the summer, you've got a cold wall, but high humidity within the air within the house. And so that's often when people are also moving things around inside the house, and so that's when they first identify it. And the permeability of the wall is very much the determining factor within the whole thing. So, what do you do about it? Quite simply, make your walls vapor permeable again. Strip them off of what is trapping that moisture behind it. It might be something as simple as getting one of the paint removal firms in, Doff or a Joff system or something like that, blasting all the plastic paint off there, and then just recoating it, providing the backing is permeable enough. If you're just going on to brickwork, normal brickwork, then that's probably going to be permeable enough, providing you've still got good quality line pointing. You might need to consider repointing in line work to restore the extra permeability that will give you on the joints, but that can be a simple aspect. Otherwise, you're looking then at a case of stripping the render right back to the background material and then replastering or re-rendering on the outside with a breathable, fully vapor permeable coating on the outside. But it needs to be done carefully and with a degree of consideration as to what you're doing on it.
What sorts of coatings would you use to make them fully breathable? Just a very weak mix of...
No, if you just go for a lime mix, start off with this, just coarse, traditional 2-3 coat build up, a coarse stuff background, perhaps a 1:6 mix, might even be a 1:4 if you want something a bit stronger, using a feeble lime or sort of inherently weak lime, and then a top coat of a 1:3 mix, and that sort of thing. Just build it up with that, and then use a fully permeable paint on top of that. Lime wash would be the traditional material, but that has a maintenance problem. You've then got to recoat perhaps every 5 years or so, because that will weather off. If you're going on to new render, then you could consider one of the masonry paints, something like Kime, something like that, which doesn't so much form a coating on the top, it will colour the top coating of the render itself. So that is a colourant rather than it's a pigmented colourant rather than a coating which will come off. But there's all sorts of things you can do with it. And as I said, but even if you're doing that, you'll sometimes find when you take the render off, you'll find that you've probably got to do a degree of repointing because of how much of, particularly if you've got a cement on there, that it will pull off the jointing. Sorry, yes?
What happens when you've got these external insulation on them?
Much the same sort of problem. Much the same sort of problem. It can cause a problem. This is where you've got to be very careful on the choice of materials that you're using. Historic England and Historic Environment Scotland have both got good guidance notes on that one, and they are always saying that it's got to be very carefully considered, so it's fully vapor permeable, so that it will allow moisture to pass through. But even so, with some of those, for instance, I was looking at one the other day, which what was that? It was a natural wool, and again, you can still have condensation problems within that, because that will still cause you a sort of that dew point within the material. Again, if you have the outside fully breathable, that will be lost, but you can end up with localized problems. So it needs to be very carefully detailed, very carefully considered as to what to use. And if you're going on to that weather listed building, if you're changing from a straight render, for which if you took off a cement render on a listed building to put a line back, you'd probably get a quite ready consent from a local conservation area. Once you introduce thermal insulation, then they're going to need full details, full justification, for that, which to some extent runs us back to what the previous speaker was talking about, EPCs. This is some of the things which is where, with work to, sort of whether you need an EPC or not, is, for instance, if you are being required to have solid wall insulation, either internally or externally, how acceptable would that be to a local authority? And that can determine whether the property warrants or needs to have an EPC in the first place. But you've got to have the EPC to determine whether you need it or not. It's one of the catch-22 things. So that is some of the more corrective actions take from it. There is also the problem of salt contamination. Where you have damp, you will very often have salts resulting from that. Because all traditional building materials have some form of mineral salt within them. It's an inherent aspect of them. If you've got rising damp, that's going to be pulling salt up from end of the ground that's with it. If it's adjacent to a highway or pavement like that, then you can introduce road salts and other contaminants from those sources, and those will come up. And very often what you will find is that you have this corona effect within the problems of a building, where the salts are coming out, which makes the problem look probably worse than it is, because the salts will sort of migrate to the surface. Some of the salts are down at the bottom there. Some of those have positive, some of those have got negative ions in them. It's for those positive and negative ions things that some people have tried to sell things like electroosmotic Dampproof cool systems, whereby they say you reverse the polarity of some of these things and you effectively drive the water out of the fabric. Yes, of course it do. So that's it. And it's very often the salts that come with the damp, either it's from whatever source, that is causing a lot of the external damage to the building, and also on the internal damage. It's this white crusting that you see internally and externally where you've got damp coming through. And that is what's happening. This is a good example here, is where you've got a hard cement mortar being used on the joints, and the moisture is coming out through the brick joints, bringing the salts that have dissolved out the fabric internally within it, gets to the outside face, and it can't dry out to the joint because the joint is impervious. It just can't get through it. So it soaks into the material on either side, where it then evaporates the external air. The moisture evaporates, and as the moisture evaporates, the soluble salts, they are left within the pores of the brick, within the stonework, or whatever material it is. Those gradually accumulate, so the crystals develop and develop and develop, and so they gradually erode, they jack off the face of the stonework or the brickwork. And so you end up with the stonework and the brickwork retreating around it, because it's effectively just been wedged, it's been blasted apart by all this salt that's been absorbed from it. And that's largely occurring because rather than having the external pointing, the external mortar as a sacrificial joint, which can be replaced quite readily every so often, it's the stonework that has been lost because the mortar is that much stronger than the material to which it's bonding. And so, as in that second picture from the left there, as a result there, you've had one owner has had to do a complete refacing on their building because of the amount of erosion that was happening to the stonework, you know, on it previously. So, it's where the use of hard cement mortar has been far more expensive in the long run than how they use a proper lime mortar. That is the sort of thing that it will affect. When you come to try and get rid of it, well, that's a somewhat problematical. The quick and easy answer is say, wash it off. Get a hose pipe and wash it off. It will disappear within seconds. And as soon as it's dried out, it will be there again. Because it just reabsorbed back into the material because you've diluted it again. So try and get rid of the damp source to start off with. Let the fabric dry out, and sort of go on from there. If you've got it on the whole area thing, you can remove it by poulticing on the thing. Particularly if you've got localised areas, if you've got nice bits of cart work, decorative work which is deteriorating, you can put some special chemical poultice on it which will draw the salts out and help to stabilise it, and you can then use a stabilising solution to restore the background material. So that will help to some extent. But for general external finishes and even dry internal finishes, because you'll find it internally, plaster's flaked away inside, and you'll find behind the plaster or behind the decorations, you'll find these white salt crystals. You'll find, again, a typical area, I forgot to mention just then, was that you'll see this bubbling in the decorations, internally or externally. You'll find, sort of, masonry paint very often will trap this behind it and end up with a very sort of poxy-looking finish with pimples and bubbles all over it. If they're not containing water, they'll very often just be dry salt crystals pockets within and behind that masonry paint. And you'll find that internally as well. The only thing that you can do then is to clean that off and then dry brush it, and keep dry brushing it on a very regular basis. But it will keep coming out as long as that moisture keeps coming and keeps drawing out of the fabric and wall. And then much the same sort of thing internally. You can have it as a problem in that area. One area which is very prone to these type of salts are the insides of large fireplaces on the older type properties. That's very often due to combustion salts and that type of thing within the whole area of the brickwork or the stonework within the fireplace where they've been absorbed over the year, and they will come back out again, you know, with the moisture that gradually dries out of the fabric. One thing which I forgot to put in these notes, which is I'll just do some sketching for the moment, just to highlight one aspect which, again, we're seeing more and more problems with all age of the properties. It's one which is typically found in upper stories of houses, usually within bedrooms. And that's where you have a bedroom ceiling, an external wall, have a roof down there, and we're very often having problems with damp, shown as black mould at high level down the wall. It can come down best part of a metre, and sometimes then often over into the ceiling, anything up to about a metre. So it comes in there, getting black mould. And this you can get on solid or cavity type construction. And it's very often caused a result of displaced insulation within a roof space. Someone's got thermal insulation within their roof, like that, and then invariably have a fully lined roof, you know, under felted, so you've got a felt type roof down there, plastic, bitumen, whatever. Will even happen with the breathable felts in some places. Invariably what happens is someone stuck their head up into the roof, or they've upgraded the roof insulation, and the insulation now has been turned up the roof, so it wedges up around like that, because people don't like the idea of having drafts in their roof space. What invariably happens then is that, much of we're talking about just now with interstitial condensation, the vapour will pass up through the ceiling, because it's inherently vapour permeable, gets up into a cold roof space. If this is ventilated, where you can get a good flow of air through, then that will just move out and it will be ventilated off. If it's all sealed in here, this gets to the top and it condenses on the felt. Felt sloping, water runs downhill, it runs down here, and this whole area here with fiberglass becomes saturated. Really gets soggy. So you've got a warm room with wet fiberglass sitting over the top of it, saturates the top of the wall here, that becomes cold, and people then complain they've got damp in the bedrooms. So again, not strictly penetrating, not strictly what we've been talking about here, but again, an increasing problem with damp in properties. Through this whole lack of ventilation, lack of permeability that we've been talking about with so many of these things so far that we've been going through here. So that's just a little one I forgot to put in what we're doing. So that brings us up to that. Any questions?
Cavity walls.